When Hernán Cortés's soldiers entered the royal warehouses of Tenochtitlan in the year 1519, they found something they did not expect alongside the gold and quetzal feathers: piles of small, wrinkled, dark seeds, stored with the same care as the precious metals. These weren't just any seeds, they were cacao. And not just any cacao, but what the Mexica called Cacao Criollo. The most valuable variety, the most aromatic, the one with the most complex flavor, the one reserved for paying tribute, for transactions between merchants, for contracts among the nobility. The tribute documents of Moctezuma II, preserved in the Codex Mendoza, record with accounting precision the quantities that each province had to deliver to the empire. Not in gold dust, not in jade, but in loads of Criollo cacao. One load was equivalent to 24,000 seeds. The provinces of Soconusco, in what is now the coast of Chiapas and Guatemala, had to deliver 400 loads annually. The arithmetic is staggering. Almost 10 million seeds a year from a single region. Cortés understood this before anyone else. In a letter to Charles V, he wrote that 100 cacao beans could buy a slave. The comparison is horrifying, but the proportionality is revealing. Criollo cacao was real money, with all that implies: recognized value, sustained demand, a system of weights and measures, documented and punished counterfeits. The Mexica knew which cacao beans had been adulterated with mud or other seeds and could detect them by touch. They had quality standards. What those seeds also contained, though neither the Mexica nor the conquistadors knew it in those terms, was a concentration of flavanols that 21st century science has identified as one of the highest documented in any plant food. And that concentration is the reason why modern cardiologists are looking at Criollo cacao with an interest that is anything but folkloric. But to understand where we've arrived, we must understand where we started. And the starting point isn't Tenochtitlan, but something much older. The plant that botanists call Theobroma bicolor, white cacao or black cacao depending on the variety and region, grew in the Amazon basin before any Mesoamerican civilization existed. Its close relative, Theobroma cacao, the cacao we know, was domesticated in the upper Amazon region at least 5,000 years ago, according to genetic analyses published by Dr. Juan Carlos Montemayor's group in collaboration with researchers from the United States Department of Agriculture. But the story of cacao as a sacred food, as currency, as medicine, that story has a specific protagonist within the Theobroma family, the Criollo varieties, the oldest, those genetically closest to the original wild cacao. Understanding the difference between Criollo and Forastero cacao takes a moment. The world's cacao beans are divided into three main genetic groups: Criollo, Forastero, and Trinitario, which is a hybrid of the first two. Forastero is hardy, productive, easy to grow, ferments quickly, and has a relatively bland flavor. Criollo is sensitive, demanding, low-yielding, ferments slowly, and has an aromatic profile of such complexity that professional tasters describe it using the vocabulary of fine wine. Notes of red fruit, tobacco, spices, damp earth, and flowers. It is also white or ivory inside, rather than the purple or violet of Forastero. And it has a flavanol content, the compounds that modern cardiovascular research has brought into sharp focus, 4 to 7 times higher than that of ordinary industrial cacao. The peoples of Mesoamerica cultivated the Creole plant for 2 millennia before any Europeans arrived. And they didn't cultivate it just to make chocolate, which didn't exist as we know it. They cultivated it to prepare ritual drinks of a complexity that would take several episodes to fully describe. Imagine yourself in Tenochtitlan around the year 1450. It's the dry season, the time of the great markets, the time for important transactions. In the Tianquistli, the Tlatelolco market, which Spanish chroniclers described as the largest they had ever seen, with more people than any market in Spain, there is a section dedicated exclusively to cacao. The vendors classify it by size, weight, aroma, and origin. Soconusco cacao is worth more than that from other regions because its beans are larger, more aromatic, and contain more cocoa butter. An experienced merchant can identify the origin of a cacao bean simply by smelling it, just as a sommelier identifies a wine region. But cacao in the market isn't just merchandise. It's an ingredient in something the Mexica called chocolatl, which has nothing to do with what that name evokes today. Chocolatl is a frothy, thick, bitter, and intensely flavored drink, prepared with roasted and ground criollo cacao, water, and a combination of additives that varies according to social rank, occasion, and region. Dried red chili, wild vanilla, achote for color, marigold flowers, and native honey. Sometimes ticitl or vanilla is added in proportions that specialists could adjust with millimeter precision. The foam was the most valued element. It was produced by pouring the liquid from one jar to another from a height, and the amount of foam was a sign of the quality of the preparation and the skill of the cook. Chocolatl wasn't for everyone. Bernardino de Sahagun's Florentine Codex explicitly describes who consumed it: the Tlatoani, priests, elite warriors, Pochteca merchants, and on specific occasions, prisoners of war before sacrifice, a final luxury before the end. It wasn't an everyday pleasure. It was a status symbol, a medicine, an offering. And as medicine, criollo cacao had a very specific function. Mexica physicians used it for the heart. Not metaphorically. The Cruz Badiano Codex, that 1552 manuscript dictated by Martín de la Cruz in Nahuatl and translated into Latin by Juan Badiano, which is the first medical treatise of the New World, describes cacao preparations to strengthen the heart muscle, relieve fatigue, and stabilize the mood in states of agitation. Mexica healers observed that warriors who drank chocolatl before long marches had better endurance, that people weakened by illness recovered their strength more quickly, that cacao relieved what we would now call states of acute stress. They were empirical observers without the biochemical nomenclature to describe what they saw, but what they saw was real. In the Soconusco, that extraordinarily fertile coastal strip of land between the foothills of the Sierra Madre and the Pacific Ocean, now divided between southeastern Chiapas and southwestern Guatemala, Mayan farmers had been cultivating criollo cacao since before the late Classic period, that is, before the 6th century CE. The cacao fields of the Soconusco were not plantations in the modern sense. They were agroforestry gardens of a complexity that contemporary agricultural systems are only beginning to grasp. The cacao grew under a canopy of shade trees, the pepeto, the palo blanco, the madre cacao, which regulated temperature, humidity, and light, created specific microclimates for each variety, and provided the organic matter the soil needed. There was no monoculture. There was a plant architecture. The Mayan farmers of Soconusco knew their plants individually. Some trees even had names. The most productive and aromatic ones were carefully tended, and their seeds were reserved for reproduction in what we would now call targeted varietal selection. The result, after centuries of selection, was a family of native varieties adapted to the specific microclimate of that region, with unique aromatic profiles that modern tasters immediately recognize as Soconusco. What the Spanish found when they arrived in Soconusco in the 1520s was an agricultural system refined over 15 centuries. What they left behind when they finished establishing the colonial regime was something very different. But before talking about the break, we must understand the second story of cocoa, the Spanish one. Hernán Cortés sent cacao to Charles V in 1528, along with instructions for its preparation. The Spanish court received it with suspicion. Bitter, dark, frothy, and unsweetened, it wasn't what European palates expected from a royal beverage. But sometime in the 1530s or 1540s, historians debate the exact date and location, whether it was in Spanish convents or at the court itself, had the idea of adding cane sugar. And with that single gesture began the most significant transformation that an American plant has undergone in modern history. Sweetened chocolate conquered Spain with a speed that even chroniclers described with astonishment. By 1580, there were already chocolate shops in Seville. By 1600, hot chocolate with sugar was the most fashionable drink in European courts. The Jesuits brought it to Rome. Genoese merchants sold it in Amsterdam. The Flemish popularized it in the Netherlands. By the end of the 17th century, virtually all of Western Europe was consuming chocolate. And here's where the problem begins. Because European demand for cacao wasn't for criollo cacao. It was for sweetened chocolate, which could be made with any variety of cacao as long as there was enough sugar to mask the bitterness. Forastero cacao, native to the Amazon and Orinoco basins, was much easier to cultivate, much more resistant to disease, and much more productive per hectare. A forastero tree produces 2 or 3 times more pods than a criollo, and once the sugar masked the bitterness, who was going to pay more for criollo? The answer to that question determines everything that came after. The growers of Soconusco and Tabasco, who had maintained native varieties for generations, faced market pressure from the 17th century onward, pushing them toward foreign varieties. The Spanish encomenderos, who controlled production and trade, prioritized yield over quality. Those planters who attempted to preserve the native variety did so at the cost of lower profitability, and in the colonial economic system, this economic disadvantage created constant pressure toward hybridization or abandonment. Hybridization is the technical mechanism behind this breakdown, and it's worth understanding precisely. Cacao is a cross-pollinated plant. Its flowers are pollinated by small flies of the genus Forcipomyia, and in mixed plantation conditions, where Criollo and Forastero varieties grow in the same area, genetic cross-pollination is practically inevitable. The result is hybrids that tend to adopt the characteristics of the Forastero variety in terms of productivity and resistance, but lose the aromatic profile and chemical composition of the Criollo. Not all at once, but gradually, tree by tree, season by season, over decades. The process wasn't deliberate in the sense that no one sat down to plan the extinction of Criollo cacao. It was the cumulative result of thousands of rational individual decisions within a flawed incentive system. Plant what yields the most, hybridize with what is most resistant, and sell to the market that pays what it pays. When an economic system rewards productivity and punishes complexity, complexity disappears. Not by decree, by simple arithmetic. Criollo cacao was, during the colonial period, doubly invisible to the authorities. It wasn't a prohibited plant like amaranth or coca. There was no royal decree ordering its eradication. What existed was something more subtle and more efficient, a market that made maintaining it more costly than abandoning it. And that, over 3 centuries, achieved what no edict could have accomplished. By 1800, when the European chocolate industry was beginning its industrial expansion, pure Criollo cacao was already a rarity. The plantations of Soconusco still had mixed populations, with some trees of identifiable Criollo lineage, but the genetic purity of the pre-Hispanic varieties was already severely compromised. The large cacao plantations of Venezuela, Ecuador, and Trinidad, which had been established in the 17th century with Criollo material from Soconusco, had followed the same path of inevitable hybridization. The 20th century finished the work that the 17th had begun. The industrialization of chocolate from the second half of the 19th century created a demand for raw materials that the world market responded to with a single solution: maximum productivity at minimum cost. The major producers, Ivory Coast, Ghana, Indonesia, cultivated Forastero cacao in high-density monocultures, using agrochemicals, without shade, and with varieties selected exclusively for yield. By 1980, Forastero cacao represented more than 95% of world production. Criollo, less than 3%. Meanwhile, in human nutrition laboratories, someone was beginning to ask uncomfortable questions about the difference between the cocoa that humanity had consumed for millennia and the cocoa it was eating now. The first systematic study to draw attention to cacao flavanols was published by American epidemiologist Norman Hollenberg in the 1990s, based on her work with the Cuna, an indigenous population of the San Blas archipelago in Panama. The Cuna, who lived on the islands and consumed large quantities of cacao, prepared without industrial fermentation or alkaline processing, a cacao that turned out to be genetically close to the Mesoamerican Criollo variety, had remarkably low rates of hypertension, coronary heart disease, and diabetes compared to the Cuna who had migrated to the mainland and adopted a Western diet. Hollenberg proposed that cacao flavanols, particularly epicatechins, might be behind this difference. The hypothesis was risky and countercultural. Cacao as a cardiovascular protector was the opposite of what cardiologists in the 1990s recommended. But the data were compelling. What Hollenberg had unknowingly discovered was a pre-Hispanic echo. The Cuna people of San Blas drank something similar to what the Mexica called chocolatl, albeit with their own regional variations, and their hearts appreciated it in a way that modern measuring instruments could not quantify. But by then, the Criollo cacao that the Mexica had kept as if it were gold was nearly extinct. Almost. Not quite. In the oldest farms of the Soconusco region, in the backyards of farming families who had resisted the pressure to hybridize, whether out of sentimental attachment or local market considerations, trees remained. Old trees, 20, 30, 40 years old, with foliage distinct from that of the foreign variety, with ears of corn smoother and paler in color, with seeds that smelled different when they opened. No one had systematically catalogued them. No one had analyzed their genetics. They were anonymous survivors of a shipwreck that no one had declared as such. And in Tabasco, in the humid valleys near Comalcalco, where the Chontal Maya had maintained continuous cacao plantations since the Classic period, there were families who still prepared a chocolate paste, without added sugar, with such an intense flavor that the first time someone accustomed to industrial chocolate tasted it, they couldn't tell if it was food or medicine. Which, it turns out, was exactly the right question. Because in the year 1996, while researchers at the International Maize and Wheat Improvement Center, known as CIMMYT, were beginning to inventory the genetic diversity of Mesoamerican crops, and while in the laboratories of the Division of Preventive Medicine at Brigham and Women's Hospital in Boston, they were designing what would be the largest clinical trial ever conducted on cacao flavanols. On a farm in Soconusco, a woman named Doña Carmen Ruiz Alonso was pruning her cacao trees without knowing that what remained on their branches was one of the most valuable genetic resources on the planet. I didn't know. Nobody had told me. And while Doña Carmen silently pruned her old trees, the large chocolate laboratories of Switzerland, Belgium, and the Netherlands had begun to patent processes for extracting cocoa flavanols, the same flavanols that the Criollo cacao of Soconusco produced naturally, without patents, without reagents, without industrial processes, to sell them as nutritional supplements at prices that no farmer in Soconusco could afford. The tree that the conquistadors used as currency had survived 500 years of colonial pressure, market-driven hybridization, and institutional neglect. But the knowledge of its value, the value that the Mexica had understood 2,000 years before the cardiologists of Boston, that knowledge had been almost entirely lost on the journey from Tenochtitlan to the shelves of European supermarkets. The flavanols in Criollo cacao are not a recent discovery. They are the rediscovery of something that was known and then forgotten. The clinical trial that changed the debate was the Cocoa Supplement and Multivitamin Outcome Study, known by its acronym COSMOS, designed by researcher Joanne Manson and her team at Brigham and Women's Hospital in Boston, affiliated with Harvard University. The study followed more than 21,000 adults over the age of 60 in the United States for an average of 3.5 years. Participants were divided into two groups, one that took a daily standardized supplement of cocoa flavanols, 540 milligrams of total flavanols, with 80 milligrams of epicatechins, and another that took an identical placebo. The participants did not know which group they were in. Neither did the researchers evaluating the results. The results, published in the American Medical Association's journal JAMA Internal Medicine in 2022, were of a magnitude not seen in cardiovascular research since the introduction of statins in the 1980s. The group taking cocoa flavanols showed a 27% reduction in cardiovascular mortality, not in the risk of a biomarker, not in a statistical projection, in actual deaths during the follow-up period. 27% fewer cardiovascular deaths in the flavanol group compared to the placebo group. To put that figure into context, statins, the most prescribed medications in the world for cardiovascular prevention, reduce mortality from coronary events by between 15 and 20% in high-risk populations, according to the most cited meta-analyses. The cocoa flavanol supplement in the COSMOS study showed a greater reduction in a general population of people over 60, without the muscular, hepatic, and metabolic side effects that statins produce in a significant proportion of patients who take them. The mechanism researchers propose to explain this effect is the endothelial nitric oxide pathway. Epicatechins in cocoa stimulate the production of nitric oxide in the cells of the vascular endothelium, the inner layer of blood vessels. Nitric oxide is a molecule that relaxes the smooth muscle of the arterial wall, reduces blood pressure, inhibits platelet aggregation, and improves the vessel's inflammatory response. Simply put, epicatechins in cocoa keep blood vessels more flexible, less prone to thrombus formation, and more efficient at transporting blood to the heart and brain. This mechanism is not new. It was first described in cell models by researchers at the National Institute of Cardiology in Mexico in the first decade of the 21st century and confirmed in human intervention studies by groups from the University of California, Davis, and the Spanish National Research Council, CSIC, through the Institute of Food Science and Technology and Nutrition in Madrid. There are more than 200 published studies on the effect of cocoa on the vascular endothelium, blood pressure, inflammation, and glucose metabolism. This is not folklore. It is one of the most active fields in cardiovascular nutrition. And now comes the part that connects that science with Criollo cocoa, and that explains why the distinction between varieties is not a detail for gourmets, but a matter of public health. The flavanol content of cocoa varies dramatically depending on the variety, cultivation process, degree of fermentation, and industrial treatment. Standard Forastero cocoa, after the conventional 5 to 7 day fermentation and high-temperature roasting used by the industry to standardize flavor, retains between 10 and 20% of the original flavanols from the bean. 80 to 90% are destroyed in the process. Criollo cacao, which has epicatechin concentrations 4 to 7 times higher than Forastero in the fresh bean, also loses some during fermentation and roasting, but it starts from such a superior base that the final product remains significantly richer in active flavanols. And there are processing methods, short fermentation, roasting at moderate temperatures, and no alkalization that preserve up to 70% of the original flavanols. The alkalization process, also known as the Dutch process, deserves special mention because it is one of the most effective flavanol destruction mechanisms that the industry has widely adopted. The Dutch process involves treating cocoa with an alkaline solution, usually potassium carbonate, to neutralize its natural acidity, darken its color, soften its flavor, and make it more water-soluble. The result is the dark, smooth cocoa powder used in most commercial chocolates and cocoa powders sold in supermarkets throughout the Spanish-speaking world. It is more palatable to those unaccustomed to the bitterness of natural cocoa, and it contains between 40 and 90% fewer flavanols than non-alkalized cocoa. In plain terms, the process that makes industrial chocolate easier to eat is exactly the process that removes most of its cardiovascular value. In 2018, researchers from the phytochemistry group at the University of Salamanca published a comparative characterization of cacao varieties in the journal Food Chemistry. This study included Criollo samples from Soconusco, Forastero varieties from West Africa, and Trinitario samples from Venezuela and Trinidad. The results confirmed that the Criollo varieties from Soconusco had concentrations of procyanidins, the largest flavanol family, 5 to 6 times higher than the African Forastero varieties under the same minimal processing conditions. Furthermore, a shorter fermentation time of 2 to 3 days instead of 5 to 7 preserved twice as many flavanols in the final product, at the cost of a more acidic and complex flavor that the mass market rejects, but which was an intrinsic characteristic of pre-Hispanic cacao. The paradox is visible from any angle. The process that made chocolate industrially popular was the process that eliminated exactly the properties that the Aztec doctors valued, that the Cuna of San Blas unknowingly preserved, and that the Cosmos study has confirmed with the rigor of a clinical trial of more than 21,000 participants. In Nicaragua, in the Huaslala region, a group of farmers organized in the Cacaonica Cooperative have been working since 2003 to recover native varieties identified by the Inter-American Institute for Cooperation on Agriculture as genetically close to the pre-Hispanic varieties of the Soconusco region. The recovery process is not simple. It requires identifying the purest adult trees of native lineage among mixed populations, taking cuttings or seeds, propagating them under controlled conditions and replanting them in agroforestry systems that replicate the shade and biodiversity conditions the native variety needs to express its full aromatic and chemical potential. It is a slow, decades-long process that does not offer the immediate economic return of outsiders and requires a commitment that conventional agricultural financing systems do not typically support. In Tabasco, the Scientific Research Center of Yucatan, in collaboration with the National Institute of Forestry, Agricultural and Livestock Research of Mexico, has spent more than 15 years cataloging the genetic diversity of the state's traditional cacao plantations. The germplasm bank they have built now contains more than 600 accessions of Mexican cacao, of which approximately 80 have been identified as being of pure or nearly pure Criollo lineage. It is a work of genetic archaeology. Each accession is a window to the past, a link between Moctezuma's garden at Huaxtepec and the Harvard laboratory that confirmed that this garden knew what it was doing. The Botanical Garden of the National Autonomous University of Mexico, UNAM, maintains specimens of Criollo cacao on its University City campus, which are part of its collection of threatened Mesoamerican plants. These are not garden plants. They are living genetic reserves. And in Soconusco, on the farm of Doña Carmen Ruiz Alonso, or more precisely, on the farm of Doña Carmen's children, which she can no longer work, there are still 12 cacao trees that the researcher Francisco Solís Nolasco from the Institute of Biology of the National Autonomous University of Mexico documented in the year 2016 as belonging to a variety that he called Soconusco antiguo, genetically distinct from any other variety cataloged in the CIMMYT bank, with a flavanol profile that in the laboratory analysis surpassed all available reference samples. 12 trees, on a single farm, representing the entire genetic variety that Mayan farmers in Soconusco refined over 15 centuries. If these stories move you as much as they move us, subscribe to the channel. Every week we open a case that time tried to close. For those who want to act on what they've heard, the first step is understanding what kind of cacao they're buying. Chocolate with documented cardiovascular benefits contains at least 70% cacao, preferably single origin, without alkalization, and with a short fermentation time. Some artisanal producers in the Soconusco region of Tabasco and Oaxaca produce chocolates of this type under verifiable origin certifications. In Mexico, the Chocolatl Artesanal brand from Tabasco, the Cool Chocolate Cooperative from Soconusco, and several producers at the Tlacolula market in Oaxaca sell cacao paste and chocolate tablets made with high-purity Criollo or Criollo Trinitario varieties, without the Dutch process and with a short, controlled fermentation time. In Spain, herbalists in Granada, Seville, and Barcelona who work with products of documented Mesoamerican origin stock Mexican and Peruvian artisanal non-alkalized cacao powders that can be used exactly as the Mexica did, mixed with hot water, without sugar or with minimal sweetener, with a pinch of ancho chili and natural vanilla. It's a preparation that tastes unlike any chocolate you've ever had. Bitter, rich, persistent, with an aftertaste that lasts for minutes. The first sip is a surprise. The second is a recognition. If you have type 2 diabetes, proceed with caution and consult your doctor beforehand. Criollo cacao has a very low glycemic index, but the fat in cocoa butter can interfere with certain medication regimens. Pregnant women should limit consumption to moderate amounts due to its caffeine and theobromine content. And those taking anticoagulants should consult their doctor before incorporating significant amounts of raw cacao into their diet, because epicatechins have antiplatelet activity that can potentiate the effect of these medications. These are not protocol warnings. They are the same caution that the Mexica ticitl applied when prescribing chocolatl to their patients. Knowledge of the context, the person, and the effect. The story of Criollo cacao has an ending that is still being written. It is neither an ending of defeat nor of complete triumph. It is an ending of partial, belated, imperfect rescue in which researchers at the Institute of Biology race against time to catalog what remains. Farmers in Soconusco and Huaslala worked to reproduce what was almost lost, and cardiologists in Boston published data that confirms with 21st century instruments what Mexica physicians observed with 15th century ones. Share this file with anyone you think needs to read it. And subscribe to this channel because the next story comes from the same source, the knowledge that he survived when no one believed in him. In 1528, Hernán Cortés sent Charles V a shipment of cacao along with a letter describing the Mexica beverage as the most substantial food and the most suitable for sustaining and nourishing the human body without tiring it. It was an imprecise phrase, written by someone who didn't fully understand what he was describing. But he wasn't wrong. 4.5 centuries later, cardiologists at Brigham and Women's Hospital in Boston reached the same conclusion. Their study involved 21,000 participants, was double-blind, included statistical analysis, and was published in JAMA. The path was longer, but the destination was the same. The seed that the Mexica treasured as gold turned out to be gold. Only the gold was flavanols, and the chest where they kept it was a tree that we almost let die.